All right, team, next video is on scientific notation and how to express numbers that are written in regular notation and switch them to scientific notation. So quick lesson on that. You have something similar to this in your notes, but just to go over what a number looks like when it's in scientific notation, you're going to have some number, and in that number, only one digit is going to be to the left of the decimal place, or the decimal point, and then you're going to multiply that number by a factor of 10, and the exponent here is really important because if that exponent is positive, it tells you that the number you're trying to express is greater than 1. If the exponent is negative, then it means that the number you're trying to express is less than 1. So we're going to refer to that as we change these numbers into scientific notation. So we're going to do a few examples from your math practice packet. This is number 3. We're going to do just a few examples here converting these numbers into scientific notation. And in order to do that, we first need to find the decimal point in the number. So if we're looking at 3a here, 9,457 kilometers, there is no decimal point written in the number, and so we need to understand that there's a decimal point at the end. So if there's no decimal point, put it at the end of the number, and then the next thing you need to do is figure out how many times you need to move that decimal point in order to make it so that you only have one digit to the left of the decimal, because that's what we need for scientific notation. So in order to get this with only one digit to the left, we would have to move that decimal point 3 times, 1, 2, 3, and then the number here, 9,457, is greater than 1. Obviously, it's much greater than 1, so that means our exponent is going to be positive, and it's going to be positive 3. So now we're going to rewrite this number with one digit to the left of the decimal, and then we need to write the rest of the digits, and then it's going to be multiplied by a power of 10, and we decided that the exponent would be 3 because we had to move the decimal point 3 times, and it's going to be positive 3 because the number here is bigger than 1. So it's going to be to the power of 3, so 10 to the 3rd power, and then you don't want to forget your units. Okay, and it's always good to just make sure that the number you wrote in scientific notation has the same amount of significant figures as the number that was originally given. So this number had 4 significant figures. The number I just wrote here also has 4 significant figures. Another thing you can do to check, there's lots of ways to check your answers here, is by using a calculator. Actually, these calculators can quickly give you scientific notation. So if you type this number, 9,457, and you use the second function, and then hit the number 5, see it says SCI, that converts it to scientific notation, so second 5, and now it says 9.457, and then this exponent means times 10 to the power of 3, which is exactly what we have written here. So that's one way you can check your work. And then when you want to go back to regular, let's put that in again. So if you want to go back to the regular form, you can go to second function, the number 4, FLO for floating decimal, will bring you back to regular. So just to show you again, 57, there's our original number, second 5 to go into scientific notation, second 4 to switch it back. So you can check your answers on your calculator too. All right, next one, we have this number. The decimal point is right here, so I need to move it in order to get one digit to the left of the decimal. So I'll need to move it 1, 2, 3, 4, 5 times. So it's going to turn into 7. And then, so that's the one digit. There's nothing after the 7, so I don't need to write any more numbers, and I shouldn't because this number has one significant figure, which means my number should also have one significant figure. Then we're going to multiply that by the power of 10. We had to move it how many times? 1, 2, 3, 4, 5 times. And this time, the number we're trying to express is less than 1. It's much smaller than 1, which means that this exponent is negative. So it's times 10 to the power of negative 5, and then our units of centimeters. Okay, so the sign of the exponent tells you if the number you're expressing is greater than 1 or less than 1. So since our number was smaller than 1, we have a negative exponent here. Okay, and then the last one, 21,000. we need to move the decimal, which isn't here, so it's at the end. Move that so that we get one digit to the left of the decimal. 1, 2, 3, 4. So we get 2.1 times some power of 10, and in this case we had to move the decimal point 4 times, and 21,000 is greater than 1, so it's going to be a positive exponent, so 10 to the 4 seconds. And again, in the last two, this one we had 1 sig fig, 1 sig fig. This one, remember those zeros are not significant, so we have 2 sig figs in this number, and we have 2 sig figs in the new number written in scientific notation. So remember that these sig figs need to match these sig figs because it's the same number. You're expressing the same number, you're just using scientific notation. Okay, and then just to remind you how to do the calculator stuff, we can also do it with these ones. So we had 0.00007, and then I want to see what that looks like in scientific notation, so I do second psi, and it says 7 times 10 to the negative 5. And then we can switch back to that. And then the other one, 21,000, second 5, 2.1 times 10 to the power of 4. Okay, so you can use your calculator to check your answers with those types of questions. All right, that's scientific notation.